Welcome, everybody. Writing code is hard, and the fundamental point these days for writing software in a way that it doesn't hurt is starting from asking a very simple question. Why do software projects ever fail? Interesting. If you ask developers why software projects ever fail, it's almost never code. It's always management. That's the point. That they are where the major responsibilities lies, because it's not the code, because the code works on my machine. And this is the issue. The code works on my machine, but my machine now is getting bigger and bigger and bigger, and is going overwhelmingly. Oh, what was that? Oh, the mic. Okay, fine. It's much better now. Is that my machine, the boundaries of my machine are exceeding overwhelmingly. I can say that. Okay, I'll find another adjective. My machine is exceeding the physical boundaries and going towards the cloud. So writing software and writing code as part of the software project is often a sad story. And this is a very short, sad, but true story of a crazy architect, oh, by the way, not me, okay, and a way too shy customer, which, by the way, is one of the companies I run as an individual, so well outside my public role of a technical evangelist, a speaker, and whatever. So the customer, let's say a company, says, well, looking at the current state of our business, we think we need some new software infrastructure that does this. A cylinder. You hire a team, a company, whatever. You have some people outside the company, because you're not that big to have a corporate developers. You hire a company, and the architect, the lead architect, says, oh, well, after looking at your domain, your business domain, I think you need this, which is not the same. It's a cube. And the question is, the cube or the cylinder? Why those tools are needed? In which way are they expected to be used? They have to fit in some way in the real-world domain. And let's say that the real-world domain has an empty hole in it. So will the cylinder fit, or will the cube fit? Probably, if the domain is large enough, I would say both can work. So this is to say that essentially sometimes there are two different ways of achieving a given abstract set of requirements. So the sad but true story ends with the architect, with the theme, building a system that actually worked, but it was not the system that the customer actually requested. And as a result, the customer, to make sense of the investment, had to slightly rework business processes in order to make the system be actually useful. This sad story happens too often, and if I have to summarize why this is bad, it's that the final system is anyway painful to use. It makes no sense at all that a company invests money to have a new software infrastructure, to have business processes change. At the beginning of my career, many years ago, when I had all of my hair, and my hair was black. I used to work for a large worldwide consulting company, by the way, one of the big sponsors here. And I remember very well that there were different, distinct set of skills in this company. One was a group of people who was focusing on business processes. They were helping customers to improve, optimize the way they were doing their own business. And then there was consulting teams, just helping building software and infrastructure, networking, whatever, to support business processes. But it's usually not a good idea if you are an architect, but even if you are a customer, to hire software experts to review your business process. They are distinct, different things. The result is systems painful to use. So, it's as a matter of fact, writing code is kind of hard. And I have now a short list of tricks, tips to relieve the impact of writing software on your own skill. The number one point, the number one suggestion is have tools to assist coding. What? Tools? I'm a developer. I have just one tool, my brain. Yes, brains. The brains is the most important tools. I think that every developer has a brain, maybe two. But brains is a kind of high-level tool. So it's a tool that does a significant job, but it cannot do everything. It controls. But other tools that concretely help with the micro tasks are important, essential as well, even more important than brains. Well, actually, brains work better. Let's put down this way. A brains works much better if it's supported, backed up by just tools, screwdrivers, the software version of a screwdriver. You never, as a developer, you never have time to tidy up your code. How many times, countless times I heard and I said myself, okay, let me write code so that it works. Let me produce code that builds successfully, that does what it's supposed to do, passes unit tests, and then at the end of the first stage, I'll sit down, relax, and clean up, tidy up my code. You never have this time. This time will never come. Accept it. It never comes that time. So, what does it mean? Because you never have the time to tidy up your code, the idea is that you should you put any effort to write the code in the final form, clean, readable, even elegant, right away, right the first time. And for this to happen, to make writing code an enjoyable experience, or at least to make writing code not a painful experience, tools that help you with auto-completion, idiomatic checks, especially idiomatic checks. So an idiom is a special variation of a language, even a programming language, that essentially uses expressions native, specific of the context of specific of the language itself in that particular business context. So an idiomatic check, for example, is checking for nullness in a programming language that supports and recognizes nulls. There are some functional languages, for example, in which if the instance, the reference is null, any following instructions is just ignored. But there are languages like C# or C++ or Java in which if you hit a null reference, that's going to be a problem, a trouble, so the code doesn't compile, or if it's not checked, you get a runtime exception. So an idiomatic check in this context is something that tells you right away if you are going to use a variable that at that point can be null. If you know this immediately, as soon as possible, as soon as it happens, you have a great chance to fix it right away so that it never happens to grow to become at some point a problem. Unused references. We complain that we happen to deploy too many libraries, too many components, too many packages. If I think of Microsoft and if I think of the new upcoming platform, ASP.NET 5 for web development on the Microsoft stack is my bread and butter, so I know it very well. And if I look at one of the commercial reasons, so to speak, behind the upcoming Microsoft new platform, one of the reasons is, oh, we want to deliver you with a much smaller footprint. But actually, if you today build with the existing Microsoft ASP.NET stack a website, and then you deploy by default to a folder, you get so many useless DLL that are there because they are added by default by the wizard to the project. But many of them are just not needed, unused. They are unused references, and you cut down 50% sometimes of the DLLs that you otherwise deploy. I had a chance to look at some courseware written by someone else on ASP.NET, and at some point I ran into a slide, very nice, because he was saying, oh, ASP.NET today is crazy platform because it forces you to have 25 DLLs when you build a project. When I deploy my projects, it's up to 5 or 6 beyond my own DLLs. And the point is unused references. I understand Visual Studio. Visual Studio does a good job in offering you a chance to reference things that possibly you need or possibly you don't need. But it's you. Well, even if you are the most expert developer, it's hard to figure out at a glance whether or not you need a given DLL. But this is where tools help. And if a tool is there, used constantly, that tells you, oh, look, it seems that you have a reference here you don't use. Get rid of that, your code comes up much smaller footprint, and faster, and anyway, oh, that code. Lines of code you just don't use. Variables that are there add noise to reading of the code, but they do nothing. And consider that the impact of that code is kind of tricky and subtle, because today there's a variable, there's a line, there's a procedure in one of your C# or Java, whatever it is, files. It's there, you don't use it, nobody tells you that that is that code, and it's there, it stays there. 6 months later, when you go back, or other people in your company go there and read the code back. And now what? Apparently, this code is not used, but it's there. It was there. It's always been there. It's there. It's been there for 3 years. And now what? Do I have the right? Am I brave enough to cut it off? Oh, yes, there are unit tests that at some point may, and if we don't have enough unit tests, if that particular segment of code is not covered by unit tests, You can make a disaster. Okay, I want to be on the safe side. I leave the code there for other 3 years. Dead code. Tools make all of these things, unused references, dead code, idiomatic checks, more elegant code in the world, just 2 or 3 clicks away. There is really no reason for not using tools, whatever tools, to make the development experience even better. Tell people when code is bad. So suppose that at some point you face code that was written probably without any help, any significant help from tools. What should you do? You don't want probably to be rude to your colleagues, to your fellow developers. But if you don't do that, if you don't approach, if you don't take any measure against code, badly written code, you don't want to hurt, but you don't want to get hurt as well. A nice way, a soft way to approach this kind of thing is just ask why the code that you think sucks was written that way. Just ask why. Why not? Learn about motivation. Maybe the code was written that way because of constraints you don't know. So there is a reason behind code that looks like it's bad. Maybe it's because of misinformation, maybe because of lack of skills, maybe because it's just a bad attitude. There might be several reasons why. But before you address the code and the coder, you might want to know as much as possible about the reasons, the real reasons that brought there. And over time, the point here, tell people when their code is bad, builds around the team an attitude to challenge other people and to be challenged by other people. This is the essence of what other people call peer programming. Be curious about the reasons. If you think that something is bad, gain evidence that can support your impression, and then, once you have evidence, ruthlessly attack. With the purpose of making everyone within a company a better developer. This means addressing the code but not the coder, the output not the producer. You want to, at the end of the day, improve the code, but not just fixing the code, but fixing the developer who wrote the code, to make it a better developer. Because any code can be fixed at any time by everybody. But if you don't fix the coder, you keep on getting bad code over and over and over again. And if you have happier developers, you have a richer team. And you have, more importantly, more assets and a richer and better company. Inspect code before you check in, which is another way of saying a popular sentence that the former American President Reagan said, talking about nuclear weapons and agreement with Russians in the 80s. Trust them, but verify they do what they are supposed to do. So check in code, but trust. Okay, trust code that developers write, but verify, which means when you check in on and the time you check in, perform automatically checks that any code being inserted into the system is compliant with a number of things, and you decide this number of things. So the point is, peer programming and regular design reviews help checking the health of code base. And I know this very well because I've been doing peer programming since '98, when my son was born. Projects don't need heroes. Okay, I know that we developers, we love to be heroes. We love to work at 4 a.m. in the morning and as young as possible. But a project that needs heroes is not really a successful project. Should not happen that developers work 80 hours a week. Okay, even for just 1 week. It makes no sense at all. There's something wrong if that happens. And if that happens, well, let's say that. Closes the door. It's a secret. Okay, let's say that. When this happens, so when we need heroes on projects, chances are that it's because of unfair deadlines. And now this opens up a whole new world of problems. Why are deadlines unfair? It's business, probably. It's sales, probably. It's lack of communication between sales and development. It's a sort of watershed compartments. Sales and development living on different planets with not enough communication in between. This is a far deeper and far more important point to raise that would deserve its own, days of, discussion. But it's a key point. When projects need heroes, most of the time, it's because of unfair deadlines. And finally, encourage practice. You know these guys, right? I mean, I'm a tennis fanatic. This guy is Roger Federer, former #1. I took this picture myself in Rome last year. This guy, one of the best tennis players in history, still trains 1 hour a day. And any other professional top player in any sport, they train 1-2 hours a day. Developers don't. Okay, we don't get as much money as Roger Federer makes. Okay, this is an excellent reason. If they paid me, I would be more than happy to train every day. But beyond this point, beyond the money that everybody makes regularly, let me say that going regularly back to the foundation of things that we use every day, in much the same way in which Roger Federer hits hundreds of forehands and backhands and serves every day, regularly, what if developers regularly, maybe not every day, but regularly, will go back to the foundation of object-oriented programming design patterns, coding strategies, or maybe certain areas of the API they are using at that time? This just refreshes knowledge, keeps you in shape, allows you, for example, to build an dependency injection mechanism like this, instead of checking, oh, let me see, what is the API? Last time I used Spring.NET. Last time I used the Unity. What was that? Bootstrap, MVC. Oh my God, I don't remember exactly. Oh, Bootstrap. You're building a web UI. Oh, okay, yes. I want to use a tab here or an accordion, but what the fuck is an accordion in Bootstrap? I need some HTML. I really don't remember. And you go get bootstrap.com, scroll, copy and paste, fix this. Yeah, it takes time. Encourage practice. And be ready to refactor. A software project begins all the time following a rather vague business idea, especially these days. And software projects today, and this is a big change we observed compared to, I don't know, 10, 15 years ago, they are moving targets. and requirements are the engine that keep the target of the software project move around. To be effective, developers should constantly be ready, mentally ready to refactor. Refactor is rewriting, fixing the code that you have today and that works to keep on working, but written in a way that is closer to the expectations, closer to the requirements, and closer to the language of the business. I mean, just a quick note, you probably have heard, whether your background is Java or .NET, you know about or have heard about domain-driven design. And one of the pillars of domain-driven design, which is the ubiquitous language, which is all about making the language of the code, so the language that results from the composition of classes and their methods, to be the same as the language being spoken by the business. And this is a fundamental point of software development today, and in practice, to achieve this goal, which is really where you get your ROI back, your return, it's money, okay? To get this, refactoring the code is all that you can do. So to be effective, every developer should constantly be ready to refactor, and refactoring, unfortunately, is one of those things that managers hardly perceive as things that bring value to the project, except, bad luck, that failing on refactoring just takes value away. So, in the end, to summarize, in the context of a project, any project with a significant lifespan, with an important business impact, writing bad code is the same as wasting your money. Writing bad code is more expensive than writing good code, because the common perception is, oh, to write good code you need more time, and more time needs more money. So it's more expensive. Don't do that, as long as the code works. But if the code that works is badly written, in the end, it will cost you a lot more than writing it rightly, correctly, the first time. Managers and developers. Managers tend to cut development costs, you hire cheap developers, and when in trouble they they gently ask to cut off on testing, maybe documentation, yeah. We have source code, come on, be serious. Documentation, what? They call this lowering the cost of producing code, because we are strongly committed. We have a company of only success stories. We want to take projects home. Unfortunately, it turns out that producing code that just works is just one part, the first and simpler part of the problem. The second part is maintaining code that just works. At the end of the day, good coding is more expensive than producing code that just works, but it's cheaper than maintaining and evolving code that just works. You need help. We developers need help, possibly expert help, whatever that means. That's all. Thank you for your time. I have, before I leave, one question, one proposal for you. I want to hit an important landmark in my Twitter number of followers. If you can prove that you've been the 4,000th follower this week, I have a special gift for you at the JetBrains booth. Thank you very much for your time, and we'll see you.